Okay, so good day, dear Makati Science High School students. This is going to be our very first lesson for geometry, and this is a new video series lesson for our subject, geometry. Our first lesson is going to be about deductive reasoning. As you may have heard, you most have heard this term from detective movies. Okay, so let's dive right into the concept. The kind of terms and statements discussed in this section comprise the deductive structure of geometry, which can be visualized through this format. So we have all the theorems on top, then we have assumptions, the actions and the postulates at the bottom, and under the underlying assumptions, they are built upon by the defined terms and the undefined terms that we will discuss or we have discussed during our previous discussion. Okay, so what are undefined and defined terms? Point, line, and surface are the terms in geometry which are by agreement not defined. Remember those three terms, point, line, and surface. Or sometimes surface can be also denoted as plane. These undefined terms begin the process of definition in geometry and underline the definitions of all other geometric terms. So that means most of the geometric terms that we will discuss here in our subject would most likely come from the definitions of these three undefined terms. Thus, we can define a triangle in terms of a polygon in terms of a geometric figure, and a geometric figure as composed of line segments or parts of lines. However, the process of definition cannot be continued further because the term line is undefined. So imagine it as a structure. Okay, so we can define what a building is. We can define what a window is, what a door is, what a room is. We can define what a surface is on the window. We can define the dust particles on the window. But beyond that reduction of definition, there comes to a point that we cannot define something anymore. So that's how you can relate it in real life. Okay, so that's one way you can relate geometry in real life as well. So there comes a point wherein the definitions are a bit murky, and yes, so most of the mathematicians, geometrists, these three basic definitions, the point, line, and the plane, they don't have specific definitions. They have specific definitions on textbooks, but they vary a lot. Okay, so again, a point is denoted by a, yeah, just like a dot, like a dot. There we go. And a line. Okay, so a point. Okay, so let's try to define a point first. A point is the space on a given plane that has no dimension. Okay, it has no dimension. It's the simplest entity in geometry, so it has no dimensions. Whereas a line is composed of infinite points. So if you have a line, you have infinite points extended from both directions. You also have a plane. A plane is composed of a two-dimensional surface that extends infinitely at all directions. Okay, so those are our undefined terms. Then we have again the defined terms. We have the two simplest ones. We have the ray. So a ray is a line segment that extends at one direction infinitely, and we also have a segment. So a segment is a delineated or it's a limited set of points. So that's how you can define them. Okay, so again, so these are the three undefined terms. We have the point, the line, and the plane. And then we have the two defined terms, the simplest ones, the ray and the segment. But there are a lot of defined terms that we will discover as we go on to the second quarter, third quarter, and fourth quarter. Then we have the assumptions. Okay, so postulates and axioms are the statements which are not proved in geometry. So we will have a lot of postulates, and these are kind of like the statements that are regarded as true in geometry without them having to be formally proven using a two-column proof or a paragraph proof. So they are called assumptions because we willingly accept them as true. These assumptions enable us to begin the process of proof in the same way that undefined terms enable us to begin the process of definition. So in geometry, it's going to be different from all of your mathematics. All of the mathematics that you've encountered so far, you are solving problems that are given to you. So you need to follow a specific set of instructions in order to find a specific answer. In geometry, it's quite the opposite. You are going to find a proof. Okay, you're given a problem, and then this proof, it can go so many ways. It can have so many ways to go to. But what matters the most in geometry is the rigor or the structure of your proofs. All of your statements must they must logically come into a story. It must form a narrative that is logically patterned. It's just logically said or stated. Okay, so there you go. And we'll try to deduce, or we'll try to find ways on how to make more logical statements in geometry as well. By of course by the underlying postulates and axioms that we will have to figure in our subject. Okay, so thus when we draw a line segment between 2 points, we justify this by using a reason. Okay, the postulate: 2 points determine one and only one straight line. So as we see, the definitions in geometry are very, what do you call it? They're very specific. Okay, so as much as possible, they try to reduce the ambiguity of the statements by giving very specific definitions. Like this, for example, a line can be determined by 2 points. Okay, so 2 points that determine only one straight line. So this reason is an assumption, since we assume it to be true without requiring further justification. It has an infinite set of points that you are going to connect each of those infinite set of points in order to create a line. So there you go. So that's why it's an assumption. You don't necessarily need to have a proof there. Whereas a theorems are statements which are to be proven or proved in geometry. By using definitions and assumptions as reasons, we deduce or prove the basic theorems. As we use each new theorem to prove still more theorems, the process of deduction grows. However, if a new theorem is used to prove a previous one, the logical sequence is violated. Okay, so for this one, it's very important in geometry that we build our new theorems from old theorems. So we can't create a new theorem. Okay, so we can't use a new theorem to prove an old theorem. Although there are exceptions to that. There are some exceptions to that. It's kind of like an addendum or a supplementary to that theorem. But as much as possible, all of the theorems that we will construct here on our Euclidean geometry subject would be based on all of the old theorems, or most especially, of course, from the postulates, and most rigorously from the definitions of a point, line, and a plane. So since those are three undefined terms, and line, segment, and ray, since those are two defined terms. Okay, and again, the defined terms, they are many. Okay, so the simplest is just the ray, and the line segment. Okay, for example, the theorem: the sum of the measures of the angles of a triangle is equal to 180 degrees, is used to prove that the sum of the measures of the angles of a pentagon is 540. Now that statement is logical, right? Because since you can create three triangles inside of a pentagon. If we're going to discuss that on polygons. So since you can create three triangles inside of a pentagon, 180 times 3, yeah, most likely you will get 540. So that suggests that there is a logical sequence to the theorems. You can't say that the sum of the measures of the angles of a pentagon is 540, and then you're going to say that the sum of the measures of a triangle is 180. It just doesn't make any logical sense. Because how can you assume first that the sum of the angles of a pentagon is 540, and then after that deducing that the sum of the angles of a triangle is 180 degrees? So there has to be a logical structure. It's kind of like in how you create your essays as well. Your arguments have to they have to be connected to each other. They have to have a relationship to each other, not just a relationship. So they have to have basis, especially when you're forming your arguments in an argumentative essay. So you'll have to have basis or claims that or evidences or research that backs up your statements. So this in turn enables us to prove that each angle of a regular polygon measures 108 degrees. Okay, so how did it become that that each individual interior angle measurement of a pentagon measures 108? Since a pentagon, okay, so let's try to draw a pentagon here. A pentagon has 5 sides. Okay, so it was already stated that the sum of the interior angle measurement of a pentagon is 540. Since it has 5 sides, 540 divided by 5, most likely you will get 108 degrees for one individual interior angle measurement of the pentagon. Okay, so therefore, do you see, can you see how these theorems follow each other? So there has to be this logical sequence, and again, this concept, this paradigm, it just doesn't work in geometry. It works in all subjects that you will encounter in your grade 8 life. Okay, so in English and Filipino and math, so you have to have proof or evidence first before you can create new ideas or new theorems. Okay, so we'll have to base that from existing theorems. Okay. However, it would be violating a logical sequence if we tried to use the last theorem to prove either of the first two. So if we said that each angle of a regular pentagon measures 108 degrees, then we're going to mention again the first two statements that we just stated a while ago, then it just wouldn't make any logical sense. Okay, so again, geometry is a starting subject for law school students. If you want to be a lawyer, or if you want to have, if you want to make good arguments, not just becoming a lawyer. So if you want to make good arguments, want to have rigor in terms of giving, expressing yourself, especially if you plan to be a politician, you plan to be a if you plan to serve in public service, if you plan to be a scientist, most likely, of course, you're going to use that. Mathematician or even just a teacher. Okay, so you have to use a lot of logic. Okay, so there you go. When we're trying to construct our arguments, and of course, you use that every day as well. When you talk to your parents, when you negotiate with your friends, when you try to bargain with other people, so you try to use logic as well. Okay, so I hope those terms were clear to you, and I hope I gave you guys a good picture on what geometry is. It's not just a subject where you're going to memorize things. Okay, so yes, memorize a lot. We're going to memorize a lot of theorems, postulates. We're going to memorize a lot of definitions. But then again, you don't learn from memorization. Okay, so the best way to learn is by discovering something on your own. And the best way to discover something is by looking at the past, trying to uncover the underlying theorems, the underlying assumptions, trying to examine them one by one, and then trying to formulate a good judgment, good decisions based on what you have searched and based on your own ideas as well. Try to amalgamate or try to combine those ideas, and you never know, you might create something as innovative as calculus, the way calculus was invented by Newton and Leibniz. And maybe, who knows, you might be the next mathematician, the new breed of mathematicians that we are looking for. Okay, so that ends lesson 1, and hopefully you've learned a lot, not just about geometry, but its interconnections with all interdisciplinary fields that uses logic.